In today's video, here is a nice number theory problem. Here is the following setup. Find all x and n as a natural number. Satisfy this following equation. We have n factorial equals x cubed minus 3x squared plus 3x minus number 4. Okay, it's very clear here. We have the left hand side of this equation is involving n factorial, but the right hand side of this equation involving a polynomial of degree 3 in terms of x. Okay, before we proceed with the solution, so I'm going to remind you about something very important here. It's necessary to use the module arithmetic here. Okay, we are going to use congruence notion. So we are going to reduce the equation to the sum module. Which module we are going to use? So you have to check an appropriate one which can reduce both sides of this equation in order to have the same remainder for both sides if the equation has a solution. If equation doesn't accept any solution, which means we will have the different remainders. Okay, so before we do that, we are going to factor out this expression as a polynomial to see how this one goes, then to check how we're gonna deal with that. Okay, and check how to make the connection between the left and the right side of this equation. Okay, first of all, let's factor out this one. Let's set f of x equals x cubed minus 3x squared plus 3x plus minus number 4. So the first idea is going to our minds. So since we have the degree 3 here, so we are going to transfer this one into the perfect cubed. Okay, so this one is going to be written as x cubed. I'm going to split this term into two terms. I get minus 2x squared minus x squared. This one also is going to be split into two terms. I get 2x plus x. This one also is going to be split into terms, minus 3 minus number 1, like this. Okay, so what's the reason why I'm doing this one? Because I'm seeking for the common factor for each two terms. Okay, so let's take this x cubed and with this x squared group it together. So I get x cubed minus x squared. Also, let's take this term with this term. I get minus 2x squared plus 2x. Okay, and group it together. Then lastly, I get x minus 1 minus 3. Okay, separately. So let's take x squared as a common factor here. So we get x squared here, factor x minus number 1. This one I'm going to take minus 2x as a common factor as well. I get x minus number 1. Lastly, I get x minus number 1 here, minus 3. So here is a common factor, x minus number 1. So we get x minus number 1 factor. This one is going to be multiplied by x squared. The second term is going to multiply by minus 2x. Last one is going to multiply by number 1, minus 3. Okay, equals x minus number 1. This one it's clearly is a x minus number 1 quaternary square. X minus number 1 quaternary square minus number 3. So now I'm going to create a perfect cube here. So I get x minus number 1 is raised to the power 3 minus number 3. Okay, so now we have n factorial equals x minus number 1 cubed minus number 3. So let's take this minus 3 to the left. I get n factorial plus number 3 equals x minus number 1 cubed. Okay, so I have ended with this nice expression. Let's take this expression at the top and continue solving this equation. Since we get to this expression, so I'm going to write this one. Let's go through the substitution. Let's put this one is the same as z cubed. Okay, notice here we know 6 factorial equals 6 is multiplied by 5 is multiplied by 4, 3, 2 and 1, like this. Okay, we know this 6 equals 3 is multiplied by 2. So here is 1 3. So how many 3 that I have here? I have 2 3s here. This one I have 9 is multiplied by capital A, for example, the bunch of numbers. This one is a congruent to 0 mod 9. Okay, so if we have for all n is super equal to 6, we have n factorial okay, which is a congruent to 0 mod 9. Okay, this, okay. Let's add number 3 on it. I get n factorial plus number 3 is a congruent to 3 mod 9, okay. Now I get the left hand side of this equation. Since I have reduced left hand side of this equation to mod 9, I get this one is a congruent to 3 mod 9. This one also. Now let's go through the chart to see what's the reminders of z cubed in order to have the comparison between the left and right side of this equation. So by going through the chart, here is a chart, here is the following values. I get k cubed, the value 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Okay, so this one I'm going to reduce it to the mod 9. Mod 9. For the following, for 0 we have 0, for 1 you get 1, for 2 cubed which is 8. 8 is the same as minus number 1. Okay, for 3 I get 3 cubed which is 27. 27 is a congruent to 0 mod 9. 4 I get 4 cubed which is 64. 64 is 1 more than 63. The remainder is number 1. 5 cubed which is 125. 125 which is 5 cubed is the same as 5 square is multiplied by 5. 5 square which is 25. 25 is minus number 2 mod 9, because we know 27 divisible by 9. So for 5, this one is multiplied by 5 equals minus 10. Minus 10, by adding number 9 on both sides I get minus number 1. This one is equivalent to minus number 1 mod 9. Let's put this one here, minus number 1. For 6 cubed is the same as 6 square is multiplied by 6. We know 6 square is 36. 9 divides 36, which is 0. You get 0 here. So I'm going to stop here because we have a kind of pattern, because I have kind of repeating here. So I'm going to stop here because I have a kind of patterns. This q cubed belongs to this set, minus number 1, 0, and 1 mod 9. Okay. But the left hand side of this equation we have a remainder 3, but we don't have my remainder 3 here. Okay, which is, it's impossible to have a solution for this equation above n is super equal to 6. Okay, which means the solution for this equation belongs to this set, 1, 2, 3, 4, and 5. Okay, so by checking case by case, this one doesn't work, this one doesn't work, this one also doesn't work, this 5 doesn't work, this okay, this works. So let's check this one, plug it into this one to see what's giving us. So we know 4 factorial plus number 3 is the same as 24 plus 3, which is 27. 27 is the same as 3 cubed. 3 cubed equals x minus number 1 cubed. Okay, so we get 3 equals x minus number 1, so which means 3 equals x minus number 1. In the other word, x equals 4. So I get the solution. I get x equals 4 correspondent to n equals 4 as well. So this is the only solution that I found for this equation. So I have ended this video. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.